So good morning friends, welcome to Water Resources Engineering class. So in today's lecture, we will take up the watershed management, then some initial abstractions which we did not really describe at the beginning of this topic, that also we will take. So this is as usual, once again reminding you that what really runoff consists of. The runoff consists of overland flow, that is surface runoff, then through flow, that is subsurface runoff, and base flow. Coming to today's lecture, first before going for watershed management, what is watershed? How to understand about a watershed? And again, one more word also we will use frequently in water resources, catchment area. So what is the watershed? What do you mean by catchment? So these are the two things first let us discuss and then go into the management part of it. So when taking up what is a watershed actually, it's an area of land. Please remember, the watershed is nothing but the area of land from which the runoff drains off into a common outlet. It is an area from which the runoff is collected through a common point. It is the geographical area of land that drains rainfall and runoff into a common outlet. What is that common outlet? Maybe a river, maybe a lake, maybe a reservoir, or finally maybe an ocean also. So the land, area of land from where the entire runoff is being collected or drained off and reaches to a common outlet, that entire area is what we call it as the watershed. This watershed may include all natural features like, for example, hills may be there, valleys may be there, small tributaries may be there, small streams may be there, but all this contribute to this outlet. Again, it acts as a hydrological unit and is bounded by natural ridges or elevation. Any watershed, if you take it, naturally it must have a boundary. That boundary line, watershed boundary line, is what we call it as the ridge line. Watershed line is also called as ridge line. The ridge line meaning itself is, it is at the highest elevation, and from that highest elevation towards the lower level, towards the valleys, the water flows and finally reach to the common outlet. So that's why any watershed has to be bounded by basically the natural ridges, or that ridge is nothing but elevation. And these lines are called as watershed lines. The watershed can be a small watershed or a large watershed, a micro watershed or a macro watershed, that depending on the size and area of the watershed. For example, you take it, Ganga river basin, if you take it, it is a large watershed. Or if you take a village stream, if you are taking, it is a small watershed. So this is fundamentally what is watershed is. What are the words that which we come across in this watershed? Number one is watershed boundary. What is that watershed boundary? Watershed boundary is nothing but the ridge line. The ridge line that separates one watershed from another. Because if you take it, suppose this is one watershed, so that means this is the ridge line. This is the highest elevation line. The entire area in between is much lower level. So naturally, from all this actually water flows like this, and finally it reaches to the outlet like here. So that means this ridge line is the highest line. Suppose if you have another watershed like this actually. So again, this is the watershed boundary for the next second watershed. So that's why this is the ridge line that separates one watershed to the other watershed, from Krishna watershed to the Godavari watershed, like that. What do you mean by streams or tributaries? They are nothing but the smaller channels that feed into the main river. The main river is the primary flow path that carries the runoff to the outlet. Outlet is the point where the entire water exits from the watershed, where the entire water exits from the watershed. And what is normally how that entire land, if you take it, the area of land of the watershed, if you take it, it may contain forests, it may contain agricultural land, it may contain urban areas also. All this will be a natural part of the catchment actually. What is the main input for the watershed? Only the rainfall is the input for the watershed. So see how the figure will be. Suppose this is a watershed. You should understand what is watershed means actually. If you see here in this particular case, normally what is the ridge line, the watershed boundary. So you see this is the watershed boundary. So this is the ridge line. So that means this is the highest point from where the water flows towards the center. And this is the main river actually. This is the main river, right? And this is the outlet, right? These are all the tributaries that are contributing to it. So from this, so the area between these two ridge lines, this is what we call it as a catchment actually. So a watershed. In this watershed actually, this is the primary river and these are all the tributaries, all are contributing towards it. So that's why these two are the highest elevations and this is at the lowest elevation, right? And some of the water may be percolated, but for all this watershed, what is the input actually? The input is nothing but the rainfall. Another figure again, suppose if you take it the precipitation. So precipitation from where all the tributaries, some lakes are there here and all that flows into the central zone, which is a river actually, and making into a sea. So that's why this line is what we call it as the ridge line. The ridge line or the mountain line, whatever you call it as, it is the highest elevation point is what we call it as ridge line. So this is the highest line. You can see the elevation also. The central one is the lowest level. So how the flows. So this total area is what we call it as a watershed. Now again one more also I have shown you. So it contains different mountains and different urban areas, different forests, all that actually. So this is one ridge line. This is another ridge line. So this is the divide and how the flows and it reaches to the lake finally. So this is how a watershed looks like, right? What is a catchment area? Because you just now learn watershed, what is a catchment area? But let me tell you all that people use watershed and catchment almost as almost a similar way. But there is a small differences are there that we will come across. So, right, watershed is on a bigger scale. Bigger scale, you need to imagine the watershed. Catchment is not that. Catchment is a specific area, specific region. Whereas if you talk about a watershed, Ganga watershed means the whole Ganga river from the starting to the ending, whatever water that adds, that entire area is what we call it as Ganga watershed actually, right? Then what is a catchment? Catchment means area from which the rainfall is collected and drained into a particular water body. Again, this is also area. Area from which rainfall is collected and drained into a particular water body, such as, for example, it may be a river, it may be a reservoir, it may be a lake. Catchment is, please note that it is a part of watershed. Catchment is a part of watershed. Catchment may be equal to watershed also, but catchment need not be always watershed. Catchment may be a part of watershed actually. It is essentially same as watershed, but it is usually used in reference to specific structure. Right? For example, if you take a Godavari river, on Godavari river, we have different structures constructed at different places. You take Krishna, we have constructed, for example, Almaty Dam is there, Nagarjuna Sagar, Srisalam Dam is there. Then we have basically, if you take it, Nagarjuna Sagar is there. Then like that, Arapulivendula barrage is there, or if you take it, Prakasam barrage is there. Different hydraulic structures we have taken. Suppose if I ask watershed, Krishna watershed means from the beginning to the end outlet, the whole thing will be the watershed. But whereas a catchment means the area from where the water is being contributed to that particular dam. To, for example, what is the catchment area at Srisalam? So what is the area that is contributing the runoff to the Srisalam dam? That is what we need to understand. Suppose Prakasam barrage catchment. So what is the area from where the runoff is being collected and is being stored near the Prakasam barrage? So that is all these are all part of Krishna watershed, but these are all specific locations we are talking about. All precipitation in this area flows toward a single point by surface runoff or through underground flow. What is the difference? Watershed is used more in the hydrological and management context. That means the entire drainage unit is being taken as one, whereas catchment area often refers to specific zone contributing to water at a particular point like a dam. Suppose if I take, this is the entire thing is what, suppose all this red line, if you take it, this is all basically the ridge line. So this is all total area is what we call it as watershed. But if suppose you ask me what is catchment area up to this point actually, right? So up to this point, whichever area is contributing this water, so this is what we call it as catchment area. This entire catchment is contributing water towards this point. Suppose similarly, see at this point, what is the thing? So whatever this is there, that is contributing to this point. So that's why catchment is always on a specific place with reference to a specific structure we can call the catchment, whereas the watershed means in a large scale from where the entire water for the entire portion of the river from the beginning to the end, that which we will take it generally. Otherwise both are used people in a similar way. People always say that the difference between these two are very, very narrow. But remember that in the hydrological and management context, we use watershed actually. For a specific zone, we use the catchment. So what do you understand by watershed management? So watershed management means what? Managing the land, managing the water resources in a watershed area. So let us say watershed is the main portion. In that watershed actually, how you are managing the land and how you are managing the water resources, that is what we call it as watershed management. But how you are managing them, the managing way is how, this is number one, in a sustainable way, that is number one. Number two, aiming to conserve soil, that is number two actually. Number three, improving the agricultural productivity, and number four, protecting the environment. So whatever you do, the watershed management, you are always handling with the land and the water resources, of course, with a view that they are all being dealt with in a sustainable way, aiming to conserve the soil and water and enhance the agricultural productivity and protect the environment. So keeping these in mind, that then whatever you do, this is what we call it as watershed management. What are the components of watershed management? Hydrological management, soil conservation, agricultural management, community participation, monitoring and evaluation. What are they actually? Hydrological management means how to go for rainwater harvesting, conservation of water, check dams, again conservation, contour bunding, again conservation, then soil conservation, terracing so that erosion can be eliminated, afforestation so that erosion can be eliminated, cover cropping actually so that soil erosion can be stopped. Soil erosion can be stopped by these methods. That is what soil conservation is. Then agricultural management, crop rotation so that naturally the yield will be very high. Organic farming actually, efficient irrigation methods such as drip, if you go for it, is agricultural management. Community participation, local people's involvement in planning and implementation of the above, that is what we call it as community participation. Apart from that, the monitoring and evaluation, regular assessment of watershed health and the effectiveness of the interventions that which you are making, so that gives you really how the better way of managing the watershed thing. Then what are the benefits of it? By proper watershed management, you can reduce the floods and drought impacts. Floods and droughts are common, but the impact of those floods and droughts can be reduced with a proper watershed management and improved water availability and quality by soil conservation or by agricultural management, by hydrologic management actually, and continuous monitoring. It helps you in improving the water resources availability and quality. Then increased agricultural, livestock and productivity so that more and more yield can be obtained by proper utilization of the water resources, enhanced biodiversity and environmental quality. Finally, empowering the local communities through employment and participation. So these are the benefits of the watershed management actually. Can you name any watershed programs in India? There are basically integrated watershed management program 1, national watershed development project for rain-fed areas is number 2. These are the two basically examples for watershed programs in India. The same thing I explained in different ways so that you can understand very easily in terms of what is the objectives of the watershed management and what are the steps in watershed management, what are the components of watershed management. Whatever I just discussed in the previous slide, same thing I explained in a different way or more elaborated way in this particular thing. Kindly see this objectives of our conservation just now: enhancement and then mitigation, basically improvement of groundwater recharge, environmental protection and ecological balance, sustainable livelihood for local communities. Right? What are the components of watershed management? Soil conservation, water management, afforestation, crop management, livestock management, and community participation. What is the steps in watershed management? This is very, very important. So it is watershed planning is one, resource mapping, actually what are the resources that all we should know. Then problem identification in the watershed. Is there any erosion problem is there? Is there any low productivity problem is there? That you need to identify, and implementation of the conservation measures and continuous monitoring and evaluation. What are the benefits? Just now we mentioned actually soil erosion can be reduced, water quality can be enhanced, water availability can be enhanced, the improved agricultural productivity, promotes biodiversity conservation, strengthens rural economy and employment. And what are the management programs? Actually, already I mentioned integrated watershed management program. Basically, that is one which we are taking up in our country. And then second one, what I already mentioned is this is the one, national watershed development for rain-fed areas. That is one. Apart from these two, in rural areas, rural infrastructure development fund is one, and the second one is MGNREGS, support for watershed works. What is that MGNREGS? Is Mahatma Gandhi National Rural Employment Guarantee Scheme. So these are the two Number 2 and number 4 are with respect to the rural areas, whereas the other two are completely, which are the national, the watershed projects actually. So that completes to me the watershed management, and I already mentioned a small portion of the first topic itself. We have not dealt in this particular unit. That is what we call it as abstractions. What are the initial abstractions that which we need to talk about? The initial abstractions are three ways actually, because these initial abstractions are also losses actually, but they are apart from evaporation, evapotranspiration, transpiration and infiltration. So they are the main. Evaporation, evapotranspiration, transpiration and infiltration are the main losses. Apart from those main losses, these are all basically the initial losses we call it as. These losses are in interception storage, depression storage and watershed leakage. These are the three other things. So that we will just have a look at these 3 points. So let me take first interception storage. Interception storage is what is the interception storage? Intercepting means what? It is obstructing. The rainfall, whatever the rainfall is there, that is being obstructed before it reaches to the ground. So before the rainfall reaches the ground, it is being intercepted. Which will intercept? Buildings may intercept, that is one, or trees may intercept actually, the leaves may intercept actually. Such type of storage is what we call, and that will not reach to the ground at all. That will be evaporated from there itself. So that small part is what we call it as interception storage. Again, read it. It is the portion of the precipitation that caught and held by vegetation, buildings and other surfaces. So that means by the time the rainfall reaches to the ground, before that itself, it is intercepted, it is stopped. That is what, before it reaches the ground. Rainfall caught on leaves, caught on the branches of trees, and water droplets resting on grass, and snow settles on tree canopies. All this what we call it as basically the interception storage. Even on the buildings, also on the top of the buildings, if some water is stored, that is also interception storage. It is temporarily stored and may later evaporate back into the atmosphere. Right? It reduces the amount of water reaching the soil, thereby influencing infiltration. Depends on vegetation type, density and rainfall characteristics. And of course, this storage is very, very minimal, but only thing is, to definition part you need to understand the portion of the precipitation that is intercepted by vegetation or buildings or other surfaces before it reaches the ground. That is what we call it as interception storage. This storage is temporary and naturally this will be evaporated and reach the atmosphere, but it won't come as a part of runoff or as a part of infiltration. So, and how much this interception storage depends on vegetation type and density. More and more trees are there, a little bit more volume of interception storage may be there. So our rainfall characteristics are slow rainfall, for example, or it is taking long time, then a little bit more may be there. Coming to the second one, depression storage. Depression storage refers to the portion of the rainfall that accumulates in small surface depressions. Suppose on the surface of the earth, a small pit is there. A small pond, don't say bigger pond, small ponds are there. Even in your house, if you take it, a small pit is there. So when the rainfall occurs, some quantity of water is being stored in that pit. That is what we call it as the depression storage. The portion of rainfall that accumulates in small surface depressions like puddles, pits, ditches, uneven land. Suppose the land is also, topography is also uneven. Even if in the lower portion, if some small quantity of water is stored, that is what we call it as depression storage. Example, potholes filled with rainwater, right? Water collected in furrows or uneven flats. So again, this is also a very small quantity of nature. This is also very temporary in nature. Then what is watershed leakage? Watershed leakage refers to the loss of water from the watershed to subsurface or adjacent basin. From the watershed, if suppose this is the watershed, from this watershed actually in the subsurface leakage or the next watershed, for the next watershed, if water leaks, such type of thing is what we call it as watershed leakage. Or if it is percolating deep in the ground but it is not contributing to this watershed, it is contributing to some other watershed, that is also watershed leakage. But all these three are very minimal amounts. Most of the cases we neglect them, but only for definition sake you need to know. The loss of water from the watershed to subsurface or adjoint basin, which is not accounted in surface flow or stream discharge. Example, water infiltrating deep into permeable geological layers and move beyond watershed boundary. Seepage from streams into the groundwater system which may not return to the watershed outlet. These are the two actually. So this completes to me what are the initial abstractions. The initial abstractions, if you take it, initial abstractions. The initial abstractions are, number one is, what is number one actually which we have studied? Number one is interception storage. Interception storage. Number two is depression storage. Number three is watershed leakage. These are only very important from definition point of view you need to understand. So this completes to me most of the second unit also. Work more on this. Again we will meet in the unit 3 of this water resources engineering in our next class. Thank you so much.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.